Hello. In this video, we're going to look at logarithms. So the definition of logarithms is that x equals a to the y is equivalent to writing y equals log base a of x for a greater than 0 and a is not equal to 1, and also when x is greater than 0. Now, all of these conditions we already know because the range for an exponential is 0 to infinity, so this value here has to be greater than 0. The base always had to be greater than 0 and also not equal to 1. Now, here's the thing. First of all, the way that we say this is log base a of x. This is not log ax, this is log base a of x. Also, this and this are inverses of each other. Now, the reason that that's important is, well, frankly, it's because, sorry, one second. If we have x equals a to the y power, the base that you see right here is the same thing as the base that you see for the logarithm. So that's base a, that's base a. What I want to be able to do is to convert between these. Now, this right here, this logarithm, you can never write log without what we call an argument, whatever log is going to act upon. In this case, the x is what we call the argument. Now, specifically what this means is that the argument must be greater than 0. In fact, that tells me what the domain is for any logarithm. The argument must be greater than 0. Now, notice that the range for a logarithm is going to be negative infinity to infinity because the domain of an exponential is all real numbers as well. And because domain and range are, excuse me, exponentials and logarithms are inverses of each other, that means that their domains and ranges are switched. All right. Let's look at some examples. We want to convert from each exponential into an equivalent logarithmic. So if we have 2 to the 4th equals 16, what I'm going to do is I'm going to write this as log base something of something equals something. Okay, and to do that, we have to realize, first of all, the base that you see here, what did I use up here for that blue? I'll use blue again. So the base of the exponential is 2, so the base of the logarithm is 2 as well. So this is log base 2 of something equals a number. Now, the reason that we have exponentials is to get the y out here by itself. That's very important. And the reason that we want to do that is because sometimes we need to be able to get to the exponent in an exponential in order to solve an equation. So if we have 2 to the 4th equals 16, that means that this 4, what did I use up here? You know what? Let's use a different color. Let's use pink there. So this 4 is going to be out here by itself. And the 16, those are kind of close. Let's use a different color. Orange. There we go. So this 4 is out here by itself. The exponent gets put out there by itself, so the 16 that you see right there is the argument. Now this looks like 2 to the 16 equals 4. It's not that. The reason that it's not that is because this is just a subscript of the entire logarithm. So here's the line, and that 2 is written as a subscript. So this is log base 2 of 16 equals 4. Alrighty, let's look at letter B. 2 to the negative 4 equals 1 over 16. Well, if you notice, the base is 2. So whenever we write the logarithm, we have log base 2 of something equals something else. Notice that the exponent is negative 4. That means that the negative 4 is out here by itself, and the 1 over 16 is the argument. Awesome. Letter C. 1/3 to the negative 2 power equals 9. Notice that the base is 1/3. So this is going to be log base 1/3 of, in this case, 9 is equal to the exponent of negative 2. Fantastic. By the way, this doesn't have to be written in this order. You can always put the exponent first. For example, over here, a to the b equals c. This is just in generic form. Notice that the exponent can be written first. So the exponent is b. So b equals, and then we write down our logarithm with our base of a of what's left over there is c. So if we want to, we can write the base first, the exponent first, followed by the log base a of c. Alrighty. Letter E. 2 to the negative 5 equals 1/32. Again, I'm going to write the exponent first, so let's start there with the negative 5. And that's equal to the log base 2 of the argument 1/32. Excellent. And now for F. Well, again, we can still begin with the exponent. So let's go ahead and begin with the exponent 0. So 0 equals the log base y of 1. And that's pretty much it there. Now, I do want to talk about a couple of things here. Notice that when your base and the argument are either both positive or both greater than 1 or both less than 1, you're going to get a positive value here. So 2 is positive, 2 is greater than 1, 16 is greater than 1, so you get a positive value. 2 and 1/16, 2 is greater than 1, but 1/16 is less than 1. You have opposites, so you get a negative. Down here, 1/3 is less than 1. 9 is greater than 1. You have opposites, so you get a negative. Same thing down here. Greater than 1, less than 1, you get a negative. Now here, because 1 is the cutoff, that means that if your argument is ever 1, you get 0, no matter what. It doesn't matter what the base is. And the reason that works is because if you look at the exponential, y to the 0 equals 1, notice that that's true no matter what y is, as long as y is a valid base. In other words, y can't be 0 here specifically. And it has to be greater than 0, not equal to 1. Alrighty. Well, there you go. I'm going to go ahead and end it here, and I will see you in the next video. Have fun.